Hello, class ninth. So, we have been studying chapter number 11, that is work and energy. Yes. So, last time we studied about work. Yes, we studied about work. Today, we will begin a new topic, that is energy. Yes. So before we start the topic energy, let's revise within 2 minutes. Within 2 minutes, let's revise whatever we studied about work. So kids, you know that what is work? Work is said to be done when a force act on an object and the object is displaced in the direction of force. Yes, work is said to be done when a force act on an object and the object is displaced in the direction of force. The work done on an object is actually the product of force and the displacement. So we know that formula of work done is equal to force multiplied by displacement. So we can write W is equal to F into S. Okay, and the unit of work is joule or Newton meter. What is 1 joule? 1 joule is the actually the amount of work done. 1 joule is actually the amount of work done when a force of 1 Newton displays an object by 1 meter. Yes. Okay. When a force of 1 meter displays the object by 1 meter, then the work done will be 1 joule or 1 Newton meter. And kids, work done by a force may be positive or negative. Yes, work done by a force will be positive if the force and displacement are in the same direction, and work done by the force will be negative if the force and displacement are in opposite direction. And the work done by a force will can also be zero if there is no different displacement. Yes, if there is no displacement is happening, then that condition work done will be zero. Okay, so the work done by a force is zero if the force is perpendicular to the displacement. Yes. Okay, if the force is perpendicular to the displacement, in that condition work done can be zero. Okay, now kids, we will study about the new topic. As you can see on the screen, yes, that is actually energy. Yes, now we will study about the energy. So first question is that what is energy? Yes, what is energy? Energy is actually the capacity to do work. Yes, energy is actually the capacity to do work. Yes, how much capacity do you have to for the work done? Yes, how much capacity do you have for work done? Yes, that will be actually energy. Yes. So kids, because energy is actually capacity to do work, so it is actually a work. When you get the energy, you start doing work. So the unit of energy and the unit of work, the unit of energy and unit of work will be same. Yes, the unit of energy and the unit of work will be same. So the unit of energy is also joule. Yes, the unit of energy is also joule. Yes, and so 1 joule is the energy required to do 1 joule of work. Yes, 1 joule is actually the energy required to do 1 joule of work. Yes, because energy is required to do any work. Yes, so 1 joule is actually the energy required to do work. But in case of work done, the definition of 1 joule is different. Yes, in case of work done, the definition of 1 joule is different. Yes, in case of work done, the definition of 1 joule was what is 1 joule? What is 1 joule? The 1 joule is actually the amount of work done. When a force of 1 Newton displaces the object by 1 meter. Yes, but in a case of energy, the definition of 1 joule is the energy required to do 1 joule of work. Yes, it is the energy, 1 joule is the energy required to do work. Well, so kids, how many uh, so can you tell me kids, how many type of energy, can you tell me how many type of energy? Well, there are different type of energy, there are different type of energy. Yes, for example, uh, mechanical energy, electrical energy, chemical energy. Yes, potential energy, geothermal energy, light energy, heat energy, solar energy. So there are different type of energy. Yes, but mainly we are going to study in this chapter only about mechanical energy. Okay, so as you can see on the screen, get 1000 joule is equal to 1 kilojoule. Yes, remember how many joule are there in 1 kilojoule? Kilojoule is actually bigger unit and joule is smaller unit. Okay, remember kids, kilojoule is bigger unit and joule is smaller unit. Okay, so 1 kilojoule is equal to 1000 joule. 1 kilojoule is equal to 1000 joule. Okay, and so there are different forms of energy. They are heat energy, light energy, electrical energy, chemical energy, mechanical energy. Yes, there are many kind of energy. And when we bust the cracker, from the cracker, two type of energy produce. Yes, when we bust the cracker, from the cracker, two type of energy produce: sound energy plus chemical energy. Yes, sound energy, because of sound energy, boom blast done by the crackers. Okay, so now kids, let's study about the mechanical energy. So mechanical energy can be divided into two parts. Kinetic energy and potential energy. Yes, kinetic energy and potential energy. So let's study about the kinetic energy. As you can see on the screen, so kinetic energy is actually energy related to motion. Yes, it is actually related to motion. Yes, so kinetic energy can be defined as the energy of an object by virtue of its motion. Energy of an object by virtue of its motion is called kinetic energy. Yes, means due to the motion the energy generated, which is called kinetic energy. Yes, due to its own motion, self motion. For example, you are sitting under a tree. Suppose you are sitting under a tree of apple. Yes, an apple tree. You are sitting under an apple tree, and suddenly an apple fall. Fall. So the falling apple has kinetic energy. Yes, because it is falling due to its own motion. Yes, so because of motion, always kinetic energy generate. Okay, so the kinetic energy of an object is the energy possessed by the object due to its motion. Yes, the kinetic energy of an object is the energy possessed by the object due to its motion. Okay, all moving object possess kinetic energy. Yes, all moving object possess kinetic energy. For example, how does the light generate? How does the electricity generate? Yes, when the water fall from the dam on the turbine rotate very fast and it generate electrical energy. Yes, when the water falls from the dam on the turbine is actually a rotating machine. Yes, so the water is falling, so it means water is in motion. So in falling water always has kinetic energy. The falling water is always has kinetic energy. Okay. uh, so all moving object possess kinetic energy. Yes, because the water is in motion, moving. For example, a falling coconut has a kinetic energy. Yes. Suppose you are riding a bicycle. Suppose you are riding a bicycle. It means the bicycle actually because of you has the kinetic energy. A speeding car, a flying aircraft also has kinetic energy. Flowing water, even the wind. Yes, in the wind, actually, when the wind blow, actually, wind contains wind energy. Yes, wind has wind energy. Or you can say air has a wind energy. Wind has wind energy. Yes, because what is wind? The moving air is called wind. So, moving air has wind energy. Moving air has wind energy, and this wind energy is utilized by windmill. This wind energy is utilized by windmill to convert into electrical energy. But the wind also has kinetic energy when the wind is blowing fast. Okay. And if you are running, it means you also generating kinetic energy. So a running man has kinetic energy. Usain Bolt, you know the meaning, or you know the name Usain Bolt, the fastest runner. So and Milka Singh, you know the Milka Singh, the flying Sikh. So when they run, they generate which energy? They generate kinetic energy. Yes. So they have kinetic energy. Okay. A running athlete have kinetic energy. Or if you have seen a cartoon movie, Incredible. Yes, if you have seen a movie, the name of movie is The Incredible, in which a little kid run very fast. Yes, because of power. So it also has a kinetic energy. Yes, the boy also has kinetic energy when in running. So these are the examples of kinetic energy. Okay. And one more point, kinetic energy depend upon the speed. Yes, if the speed of the object is uh, faster, okay, then the kinetic energy will be more. Yes, an object moving faster has more kinetic energy. Yes, an object moving faster has more kinetic energy and then an object moving slower. Yes, because the object which is moving slow will have less kinetic energy. Okay. Now, kids, let's see the derivation related to kinetic energy. Okay, kinetic energy actually denoted by a symbol which is EK. The symbol of kinetic energy is EK. Okay, capital E, and the K we write just at the bottom on the right side. Okay, let's move on the next point. Okay, so let's see the derivation related to kinetic energy. So, the kinetic energy possessed by an object of a mass m and moving with uniform velocity v is equal to Ek is equal to 1 by 2 mv square. What is the meaning? Because moving object always has kinetic energy. Yes, if the object is moving faster, then it has more kinetic energy. Yes, suppose there is an object who is moving fast. The object is moving fast, and the velocity of the object is v. Suppose it is moving with uniform velocity, which is v, and the mass of object is m. Okay, because everyone has mass, even the air has mass. Okay, so what will be the energy if the object of mass m and moving with the velocity, uniform velocity v? Then the kinetic energy will be Ek is equal to 1 by 2 mv square. Yes, this is the formula of kinetic energy. Yes, this is the formula of kinetic energy. Ek is equal to 1 by 2 mv square. Okay. Let's solve the question which is based on this formula. Okay. Because kinetic energy is actually a form of energy, so the unit of kinetic energy will also be joule. Okay, don't get confused. Okay, so the question is, as you can see on the screen, I am reading the question. An object of mass 50 kilogram is moving with a uniform velocity 4 meter per second inverse or meter second. What is the kinetic energy possessed by the object? Okay, so the question is, there is an object whose mass is 50 kilogram and it is moving very fast. Yes, the object of 50 kilogram, it is moving very fast, and it is moving with uniform velocity. So what is the velocity? The velocity is 4. So what will be the kinetic energy? What is the kinetic energy possessed by the object? Yes. So we know the formula. Ek is equal to 1 by 2 mv square. We know the formula Ek is equal to 1 by 2 mv square, as you can see on the screen. So here m is equal to 15 kilogram. M is equal to 15 kilogram and V is equal to 4 meters per second inverse. Yes, 4 meter second inverse. So we will put the value. So when we will put the value in the place of M, we will write 15, and the place of V, we will write 4 square. Yes, square of 4. So it will become 1 by 2 multiplied by 1 by 2 into 15 into 4 into 4. Yes, because here we have V square, so that's why we will put the value of V 2 times. So we will write 4 into 4. Okay, so 1 by 2 into 15 into 4 into 4. Then when we will solve this question, we will get the value which is 120 joule. 120 joule will be the value of kinetic energy. Why we have used J here? Because J is actually the symbol for joule. Okay. So the kinetic energy of the object is 120 joule. Yes, it's very easy. Now let's study about the potential energy. Let's move on the next point. Okay, so what is potential energy? Let's study the topic. So you already know kinetic energy. Yes, you already know kinetic energy. The kinetic energy of an object is the energy possessed by the object due to its motion. Yes, possessed by an object due to its motion. And potential energy is actually a stored energy. Yes, potential energy is actually a stored energy because of its position. Yes, because of its position or shape. Yes. So what is potential energy? Potential energy is the energy of the object by virtue of its position or shape. Yes, it is stored energy. So as you can see the definition on the screen, I am reading the definition. The potential energy of an object, is the energy possessed by the object due to its position or shape. Yes, the potential energy of an object is the energy possessed by the object due to its position or shape. Okay. Kids, when few minutes ago when we studied the topic kinetic energy, I gave you one example. I gave you one example that when the water falls, when the water falls from the dam on the turbine rotate and generate electrical energy, and falling water always has kinetic energy. But what what if the water is not falling? Means water is in the dam. Yes, water is in the dam. Okay, so because of its shape and position, the water will have which energy? Potential energy. Yes, the water in the dam always has potential energy, but when it will fall, the potential energy will convert into kinetic energy. Yes, it means we can say that energy can also be converted. Energy can also be converted. Okay, because position means the water is in the dam, and if it will fall on the turbine, it is in the moving and it got the kinetic energy. When the water will store again, it will get the same shape of the dam, so it will all again get the potential energy. Yes. Okay. Suppose you have a rubber band. Okay, suppose can say you have a rubber band. If you try to stretch and then release it, you stretch and release it, then what will happen? After releasing the rubber band, it will gain its original shape. Why? Why? Because when the rubber band is stretched, actually the energy is transferred and stored. Yes, when you release the rubber band, the energy automatically is storing in it. That is actually as potential energy. Because of potential energy, the this energy which is possessed in the object, because of its position and shape, that's why the rubber band got the again the same come into the original position and original shape. Yes, so if a rubber band is stretched, then release it and regain its original position when the rubber band is released, because the energy is transferred to it. Yes, and is stored as a potential energy, and we know that potential energy is the energy due to its position or shape. Yes. One more example, as you can see on the screen, if we wind the key of a toy car. Yes, if we wind, yes, you know the toy car, wind the key of toy car यानी कार की चाबी को घुमाना. If we wind the key of toy car and place it on the ground, what will happen? Because of winding the key of the toy car, the car will start moving. Yes. Actually, when we wind the key of the car, energy is transferred to the spring. Yes, which is actually inside the car. So energy is transferred to the spring inside and stored as potential energy. Yes, stored as potential energy. Yes, stored as potential energy. So it will move. The car will move, and after some time it will stop. Yes, it will back to its original position. Yes, it means what is happening? It is coming to its original position, means what is happening? It is regaining its position and storing the potential energy. Yes, the energy is transferred to the car and stored as potential energy. One more example, if we lift any object to a height and release it, if we lift any object to a height and release it, it falls down. Definitely it will fall down. Yes, when the object is lifted, then actually the energy is transferring. When you are lifting the object, actually the energy is transferring to the object and it is storing as potential energy. Yes, and when you lift the object, when you release the object, then the object fall down and it will come to its original position, and the object is coming to its original position. So it means it has stored potential energy. Yes, so that is like the meaning of potential energy. Yes, due to its position or shape. I hope you understood the meaning of potential energy. Now let's move on the next point. Okay, it's time to ask question from you. Question number one. Define energy, write its unit, write the different forms of energy. Yes. So what is energy? The energy of an object is its capacity for doing work. Yes. The capacity to do work is called energy. And the unit of energy is joule. 1 kilojoule is equal to 1000 joule. And there are different forms of energy. And they are heat energy, light energy, electrical energy, chemical energy, mechanical energy. Mechanical energy also divided into two parts: potential energy and kinetic energy. Question number two. What is 1 joule? Yes. So 1 joule. If I talk about in terms of energy, then in terms of energy, 1 joule is actually the required energy to do 1 joule of work. Yes, 1 joule is the required energy to do 1 joule of work. But if I talk in terms of work done, then 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Yes, 1 joule is the amount of work done when a force of 1 Newton displaces an object by 1 meter. Question number 3. What is kinetic energy? What is kinetic energy? Write its formula. Yes, what is kinetic energy? The kinetic energy of an object, the kinetic energy of the object is the energy possessed by the object due to its motion. Yes, all moving object possess kinetic energy. For example, falling coconut, falling water, blowing wind, running athlete. The formula of kinetic energy is the kinetic energy is denoted by ek. The kinetic energy is denoted by ek. Kinetic energy is equal to 1 by 2 mv square. Okay, this is the formula of kinetic energy, 1 by 2 mv square. Question number 4. Yes. Question number 4 is what is potential energy? Explain potential energy with example. Yes. So the potential energy of an object, the potential energy of an object is the energy possessed by the object due to its position or shape. Yes, due to its position or shape. For example, if a rubber band is stretched, then released, then the rubber band gain its original shape because when the rubber band was stretched, its energy is transferred to and is stored as a potential energy. Next example is if we wind the key of a toy car and place it on the ground, it moves. When we wind the key of the car, then actually energy is transferred to the spring inside and is stored as potential energy. That's why after some time the car gets its original position, means it stops. Okay. I hope you understood. Now we'll meet in next class. Okay, and we will study something more in detail about potential energy, and we will study one law. We will also study about the power. We will meet in next class. Till then, bye bye.